Imagine looking at a clock. The seconds are moving normally. Tick, tick, tick. Then suddenly, the clock slows down. A second feels longer. Then time speeds up. And finally, it stops. Sounds impossible, right? But recently, a physicist created what researchers describe as a mini-universe inside a laboratory. And inside this strange quantum system, time appeared to speed up, slow down, and even effectively stop. But here's the terrifying question. What if time isn't a fundamental part of reality at all? What if time only exists because things change? Welcome to Curious Orbit. And today, we're entering a universe where time doesn't need a clock. Scientists have struggled with one strange question for decades. What exactly is time? We use clocks. We count seconds. We measure days and years. But a clock doesn't create time. It only measures change. Earth rotates. Atoms oscillate. Machines vibrate. Something changes. And we call the measurement of that change time. But when physicists try to combine quantum mechanics with our understanding of the entire universe, something very strange happens. In some theoretical descriptions of the universe, at its deepest level, time seems to disappear. One famous example is the Wheeler-DeWitt equation. Unlike the physics we experience every day, this equation doesn't contain an ordinary external time variable. It's almost as if the universe, viewed as one complete quantum system, doesn't have a giant cosmic clock ticking outside it. And that creates a huge problem. If the universe doesn't have an external clock, where does time come from? To investigate this question, Professor Giovanni Barantini at the University of Birmingham created an extraordinary experiment. He used approximately 24,000 rubidium atoms. But these weren't ordinary atoms behaving normally. The atoms were cooled incredibly close to absolute zero. At temperatures this extreme, atoms can form a bizarre state of matter called a Bose-Einstein condensate. Instead of behaving like thousands of completely separate particles, the atoms can act collectively like one giant quantum object. Scientists then use this system as a simplified model, a tiny quantum universe. Not a real universe filled with galaxies, stars, or planets, but a controlled quantum system designed to explore ideas about time and cosmology. The system was divided into two regions. One was called the bright sector. The other was the dark sector. Atoms could move between these regions, but researchers focused on information available from inside the system. As atoms moved, the distribution of particles changed. The system became more or less spread out. This change is connected to something called entropy. Entropy is often described as disorder. Imagine a perfectly clean room. Everything is organized. Then 20 people enter and start moving objects around. Over time, the room becomes more disordered. That's a simple way to imagine increasing entropy. And entropy is deeply connected to what physicists call the arrow of time. You remember yesterday, but you don't remember tomorrow. An egg can fall and break, but a broken egg doesn't normally jump from the floor and perfectly rebuild itself. Why? One major part of the answer involves entropy. Physical systems tend to move toward more probable, more spread out states, and this gives time an apparent direction, past to future. Inside the mini-universe experiment, researchers tracked changes in entropy, and something incredible happened. They could use these internal changes as a clock. No ordinary clock inside the mini-universe. No person counting seconds. The system's own changing state created a way to order events. When entropy changed rapidly, the internal entropic clock moved faster. When entropy changed more slowly, the clock slowed down. And when the relevant distribution stopped changing, the entropic clock effectively stopped. Now, this is important. The scientists did not freeze time in the laboratory. People outside the experiment didn't suddenly stop moving. The Earth didn't pause. The researchers' watch continued ticking normally. What stopped was the flow of this internally defined measure of time. And that difference is extremely important, because the experiment suggests something fascinating. Time may not always need to be fundamental. It may emerge from relationships and changes inside a physical system. Think about that. Maybe time isn't a river flowing through the universe. Maybe there isn't a universal clock somewhere in reality. Maybe time is simply the way changing systems keep track of their own history. Imagine a universe where absolutely nothing changes. No atoms move. No stars burn. No particles interact. Nothing decays. Nothing expands. Every single part of reality remains perfectly identical forever. Would time still be passing? Or would the idea of time become meaningless? That's the mystery scientists are trying to understand. And the mini-universe experiment may give physicists a new way to test these ideas. The system could even model expansion and contraction. In simplified terms, researchers could observe behavior resembling a tiny cosmos expanding and then contracting, something conceptually similar to a big bang followed by a big crunch. Scientists hope experiments like this could help explore questions connected to the early universe. Quantum gravity, and possibly simulated black hole physics. But the biggest question remains, if time can emerge inside a small quantum system, could time in our universe have emerged in a similar way? Before the Big Bang, people often ask, what happened before? But maybe that question is wrong, because if time itself emerged with the universe, there may be no before. It's like asking, what is north of the North Pole? The question assumes a direction that may no longer exist. And here's where things become even stranger. If time depends on internal changes, then the universe may not experience time in the simple way humans imagine it. Seconds, minutes, hours. These are our measurements, our clocks, our systems. But reality, at its deepest quantum level, may be operating under completely different rules. Scientists haven't solved the mystery of time. This experiment doesn't prove that time is an illusion. And scientists did not create a real universe or literally stop time. But for the first time, researchers now have a laboratory system where they can experimentally explore how a version of time may emerge from within a quantum system itself, a universe with no external clock, a system creating its own history, and perhaps a small clue to one of the biggest mysteries in existence. What is time? So the next time you look at a clock, remember, you may not be watching time itself. You may simply be watching change. But what do you think? Is time a fundamental part of reality, or is it something the universe creates as it changes? Comment your theory below. And if you love mysteries about space, science, and reality, subscribe to Curious Orbit, because the universe is much stranger than it looks.